Peace be upon you, ninth graders. Recall that single covalent bonding is sharing of one pair of electrons. This means two electrons each coming from one atom. Example, in hydrogen molecule, each hydrogen shares one pair of electrons with the other hydrogen atom, forming one single covalent bond. In CH4 molecule, the carbon atom shares one pair of electrons with each of the four hydrogen atoms, forming four single covalent bonds. In H2O molecule, the oxygen molecule shares one pair of electrons with each of the two hydrogen atoms, forming two single covalent bonds. And in this video, we'll explain in details how double and triple covalent bonds are formed. Starting by the double covalent bond. Let's take an example, the oxygen molecule O2. What is the type of bond between the two oxygen atoms? How many electrons does an oxygen atom have? It has 1, 2, 3, 4, 5, and 6 valence electrons on its valence shell. How many electrons are needed for oxygen to achieve the stable electron configuration of neon, which is a stability with 8 electrons? It needs 2 electrons. So the oxygen atom will share 2 pairs of electrons with the other oxygen atom to form a double covalent bond. Do you remember the Lewis dot symbol of oxygen atom? Okay, now you have to try writing the Lewis dot structure of the oxygen molecule. First, we write the Lewis dot symbols of the two oxygen atoms, where the lone electrons are put opposite to each other. Then, we join these lone electrons. So we get the Lewis dot structure of the oxygen molecule O2, and the two pairs of electrons joining the two atoms are called double covalent bond, and it is represented by 2 dashes between the two atoms. Let's apply. Consider the Lewis dot symbols of the carbon and oxygen atoms. In A, we have to identify the valency of carbon and oxygen atoms. Then explain the bond formation in the carbon dioxide gas CO2 and deduce the Lewis dot structure of CO2. Carbon has 4 lone electrons in its Lewis dot symbol, then the valency of carbon is 4. Oxygen has 2 lone electrons in its Lewis dot symbol, then the valency of oxygen is 2. In explaining the bond formation in carbon dioxide, we say that the valency of carbon is 4, then carbon needs 4 electrons to become stable and satisfy octet rule. The valency of oxygen is 2, then oxygen needs 2 electrons to become stable and satisfy octet rule, which is stability with 8 electrons. Then, in CO2, carbon atom shares 2 pairs of electrons with each of the 2 oxygen atoms, forming 2 double covalent bonds. And here is the Lewis dot structure of CO2. We write the Lewis dot symbols of the carbon and oxygen atoms and put the lone electrons opposite each other and then join each 2 lone electrons to get 2 double covalent bonds. And now we are going to talk about the triple covalent bonding. Let us investigate the type of bond between the 2 nitrogen atoms in the nitrogen molecule N2. How many valence electrons does a nitrogen atom have? It has 1, 2, 3, 4, and 5 valence electrons on its valence shell. So how many electrons are needed for nitrogen to achieve the stable electron configuration of neon gas, which is the stability with 8 electrons? It needs 3 electrons. So nitrogen atom will share 3 pairs of electrons with the other nitrogen atom, forming a triple covalent bond. Do you remember the Lewis dot symbol of nitrogen atom? Okay, let's try now writing the Lewis dot structure of a nitrogen molecule. First, you have to write the Lewis dot symbols of the two nitrogen atoms, and the lone electrons must be put opposite to each other. Then join these lone electrons. So we'll get a triple covalent bonding. This is the Lewis dot structure of nitrogen molecule N2. And the 3 pairs of electrons joining the two atoms are called a triple covalent bond, and it is represented by 3 dashes between the two atoms. To sum up, let us compare the types of bonds between the two oxygen atoms in the oxygen molecule O2 and between the two nitrogen atoms in the nitrogen molecule N2. In the oxygen molecule, there is sharing of 2 pairs of electrons between the two oxygen atoms, forming a double covalent bond. And in the nitrogen molecule, there is sharing of 3 pairs of electrons between the two nitrogen atoms, forming a triple covalent bond. Let's do the second application. Consider the Lewis dot symbols of carbon and hydrogen atoms. First, we have to identify the valency of carbon and hydrogen atoms, then explain the bond formation in ethene C2H2, and finally deduce the Lewis dot structure of C2H2. First, the carbon has 4 lone electrons in its Lewis dot symbol, then the valency of carbon is 4. And hydrogen has 1 lone electron in its Lewis dot symbol, then the valency of hydrogen is 1. In explaining the bond formation, we say that the valency of carbon is 4, then carbon needs 4 electrons to become stable and satisfy octet rule, and the valency of hydrogen is 1, then hydrogen needs 1 electron to become stable and satisfy duet rule. Then, in C2H2, a carbon will share 3 pairs of electrons with the other carbon atom, forming a triple covalent bond, and each carbon atom will share 1 pair of electrons with each of the 2 hydrogen atoms, forming 2 single covalent bonds. And here is how to write the Lewis dot structure of C2H2. First, we write the Lewis dot symbols of the 2 carbon and the 2 hydrogen atoms, then put the lone electrons opposite to each other, then join them to get the Lewis dot structure of C2H2. Keep in mind that double covalent bonding is the sharing of 2 bonding electrons between 2 atoms. This means the sharing of 4 electrons where each 2 electrons come from an atom. Example, an oxygen molecule, the oxygen atom shares 2 pairs of electrons with the other oxygen atom, forming 1 double covalent bond. And in CH2, the carbon atom shares 2 pairs of electrons with each of the 2 oxygen atoms, forming 2 double covalent bonds. And that triple covalent bonding is the sharing of 3 bonding electron pairs between 2 atoms. This means the sharing of 6 electrons where each 3 electrons come from an atom. Example, in the nitrogen molecule, each nitrogen atom shares 3 pairs of electrons with the other nitrogen atom, forming 1 triple covalent bond. And in C2H2, the carbon atom shares 3 pairs of electrons with the other carbon atom, forming 1 triple covalent bond.